So today we're going to review over some of the properties with logarithms that we have talked about, and we're going to introduce a new logarithm called the natural log. So the one base that we spoke on last class period was called the common log. If a logarithm does not have a base, then it is understood to be a base 10. So the calculators are set to use base 10. So when you see just log in a calculator, it's set for your base 10. Now, log base 10 and exponent base 10 are inverses of each other. So when you have them, it's going to cancel out to a 1. So in your calculator, for the regular log feature, you're going to see that it is right there on the far left side. So if you use that feature, you can see that the inverse is above that. So above the word log is an exponential. So those are inverses of each other, just like your square and your square root. So if you hit the button log, and we know that's a base 10, and you put a base 10 for an exponent, those would cancel out to 1 because they are inverses of each other. Now, the natural log is pronounced ln. So we discussed the number e when we dealt with our PERT formula with continuous compounding. When we look at this today, we know that e is approximately the number 2.71828. It's irrational, just like pi. So when we looked at e in the calculator, if you remember, it was on the divide button. So when you did the divide right here, you could have used e, which was second divide. You can type that in and you would see the approximate number value there. So when you are wanting to raise e to other powers, it's going to be right there with your ln, because ln and e are inverses of each other. So it's going to be right with your ln. So if I'm going to raise e to the third power, I will get that number. So there's your e button. Your ln button is going to be right there. So if I was to take ln of 3, I would get this number. So those would be inverses of each other. So if we were to type in ln, since this is e to the first, I'm just going to use this button over here, second divide, and I'm going to close the parentheses, and I get 1. So remember that inverses cancel each other out. So that would cancel out to 1. And that's going to be very helpful when you solve equations, because remember, to get something to cancel out, we always use the inverse operations. So they would go away. Now, if you want to use the button over here with your ln, when you go back to that, hit second e and just put 1 for the first power, and you would get your 1 as well. So if you'll just get maybe a sticky, and I'll show you how this inverse works in an equation. So if you notice, we have 8 to the x power. I cannot write 13 with a base of 2 that is a factor of 8. I cannot write 13 with a base of 4. And I'm unable to write 13 with a base of 8. So when you can't get the bases the same, that's when you are going to need to use your logarithms, where you can actually find an answer, okay? So think back for a moment of how we can actually get this exponent to come down, okay? Okay, if you remember me discussing, we can expand this by actually putting the word log there. Now, this time we're going to have to pick a base, and I want to pick the base of 8 for this logarithm because what I know is if I get my base of my logarithm and my base of my exponential, then this would cancel out this side right here. Okay, so when this cancels out, that just means x times 1, which means I'm isolating my x, which would be x. And now I taught you how to type this into your calculator already. So we're going to go and we're going to hit the word alpha. Then we're going to go to window. We're going to go down to number 5. So we're going to have log base 18 of 13. So we're going to get an approximate number. So I'm going to round this 4 places. So this 7 will bump the 4 up to a 5. So this would be approximately 1.23335. That would be your approximate decimal for that answer. So if I was to check this, I'm going to now take my 8 and I'm going to put my 8 and I'm going to raise it to the answer that I just received. And I get 13. So that's how you can get an answer for something that is very, very difficult to write as the same base, because that one was not possible. And another way you could solve the problem is through using natural logs. So they're going to have the same properties of where, since I cannot do this, I'm going to drop this in front, and it's going to be in front of the 8 now. So I'm going to have x, and when I drop it, I want to use ln. So I'm going to use ln of 8, and then I'm going to use ln of 13. Now, to be able to solve this, I can now divide by this ln of 8. And then those two would inverse out that way. So I'm going to go to ln of 13, and I'm going to divide that to ln of 8. And see, I get that approximate decimal again, 1.2335. So you can solve, with your same bases as inverses, or you can use your ln and then divide to get your x value here. So if you were trying to find what to raise e to the power 2 to get 83, and that would be very difficult since e is that decimal right here that keeps going forever. What you would need to use is to know that ln and e are inverses. So we can drop this power in front, and we can write ln of e. And since I ln this side, I need to ln the opposite side. So when I look at that, the ln times e, if you remember, is going to go to 1. So that's essentially going to be x. And then you would type in ln 83. So you would go down here to your ln button, and you would hit 83 and enter. And so you would get approximately, and we're just going to go 4 places every time. I think that's about what the computer might ask you. So it'll be 4.4188. So that 4 right there will not bump this 8 up. So if I was to check this, because sometimes they're going to want exact answers, and we're going to talk about that in a minute. If I was to check that, I would do second E, and I would do second answer, and then you would see that E to that power would give you 83. So that's why these are important to know. So you're going to be able to solve equations with this. Okay, the next rule that we discussed briefly in class is the change of base rule. Now, calculators are programmed to do base 10, and you will need to know this rule even if we can type the decimal in the other way that I showed you, because this would be how you would type in an exact answer. So when you talk about exact answers, that means you're not rounding. It's kind of like you're going to leave them in terms of logs or LNs. When you do an exact answer with a radical, we leave it in terms of the radical. So sometimes you will need to type it in this way, so you'll need to know the rule. So when you have log and you have the base right here of that logarithm, whatever that base is, that base is going to go in the basement. So the log base is going to go in the basement, which means it's going to go on the bottom when you type this in. So we're going to practice typing this in without using the alpha window. When you look at the other part, the log of this one is going to go on top. So this one would go on the top portion. So the X, notice, goes on the top, while the bottom right here goes on the bottom because it's on the bottom. You're going to use whatever the base is, okay, and you're going to put it on the bottom. Whatever the top is going to go on the top. If you'll go back and take out those B's, I didn't mean to put that. So you're going to put the log, because this is what you're going to have on the bottom, the log of A, and then what you're going to have on top is the log of X, okay? So the base of the logarithm is in the basement. The top of the logarithm is on top, okay? So let's look at an example with some numbers. So right here, when you find the base of the logarithm, remember we talked about that's the important part. You're going to write that first. So we're going to put the word log. We'll put log. So then we're going to put this 2 right here. So we're going to have log base 2 is on the bottom, and this one is going to go on the top. So it would be log 3 over log 2. So I wanted to show you that you would get the same number value. So when you look at those numbers, they're the same, okay? But when it wants you to put an exact answer, you're not going to be able to put it 1.5850. You're going to have to put this right here into the computer. So this would be considered exact. Okay, so we're going to practice right now putting them in as an exact. So we're going to leave ours in terms of this fraction, and then we will go back and evaluate it, okay? Because sometimes when you do an exact number, it could come out to be a whole number, because an exact square root of the square root of 4 is 2. But if you were to do the square root of 2, the exact number for that is not the decimal, it would be the square root of 2. That means there's no rounding involved, okay? So before we actually use the calculator to evaluate, let's use our change of base formula for the logs, okay? Okay, so if you'll jump to the one that says change of base formula. So when we go to number 5, if you'll go ahead and try that one based on what I discussed. So if you'll leave the exact answer, and then if you will round it to 4 places, if it goes 4 places. So as you return, remember that this one is going to go on the bottom. So we're going to write the word log on the top and the bottom. And we're going to put the base of 1/4 and then this base of 5. That's going to be there. Log of 1/4 and then log of 5. Now the other part, which is the number that is big right there, is going to be on top. And this 2 is going to be on top. So that would be your exact answer. So this would be exact if it tells you anything about exact or change of base. So now we'll do the approximate, just using this formula. So I'm going to type in the log of 17 divided by the log of 5. And so that would be 1.7604. So this would be rounded. So that's why I'm doing approximate. Okay, if you want to double check yourself, you can always go back to what I showed you the other day and hit alpha, window, and go down to number 5 and do it this way. If you want to check and make sure that you typed it in correctly. So that would be log base 5 of 17. And then you can see those numbers would be equivalent. So log base 2 or log base 1/4 of 2. So I'm going to type in log 2 divided by log of 1/4. So that would come out to, that's actually an equal number, so we're not approximating. So I'm going to change that to equal because it actually is equivalent to that number. So that number would be -0.5 or -1/2. Because remember, you could do math, enter. Just pay attention to what it's asking you to put, okay? Now, if you'll grab like a little sticky, we're going to talk a little bit more about that on the right side, or another little sheet. Okay, so if you see the natural log of the ln of 24, remember that you can write that as a logarithm with base e. Okay, so let's first of all type in ln of 24. So remember that button's on the left. So we're going to do ln of 24 and hit enter. So the natural log of 24, we're going to round. So we're going to do approximately 3.17. That 5 is going to bump the 0 up to a 1, 3.1781. So we're going to kind of box that number because I'm going to show you how you can actually change this stuff around. So ln can be written again as your log base e. Okay. So then if you did a change of base formula with that, then you would keep the base e in the basement. So this would be the one that would go on the bottom. So we would have log e. And then on top, you would have log 24. Okay, so we're going to type that in and see if we get the same decimal. So we're going to type in log 24 divided by log e. Remember, if you just want it to the first, do second plus. So we get that same number, 3.1781. So this would be your exact, and then we double check to get the approximate to make sure it would be the same. Right there. Okay. Now, when you are looking at that information, like a while ago when we did the change of base formula, I want you to understand that it can also work with LNs as well. So when you do the log of B on top and the log of A on bottom, because remember, keep the base of the log in the basement, you can get the same thing as if you did the natural log of B over the natural log of A. So those can work as well. So let's go back over here after you've copied that. And I'm just going to kind of come down here and we're going to try to do the natural log of 17 and the natural log of 5. And you see that you get that 1.7604. Sorry, that we got right here. Okay. So you can do the log, and that's probably what they're going to want in the computer. If they ever ask you to do the LN, I just want you to know that that will work as well. So I just did the other one with your LN, 2 divided by LN of 1/4. And you see that you would get that as well. So just another way to check and kind of understand that those two are just two different ways to work the problem that's going to yield the same solution. Okay. Now that I kind of gave you an idea of how a lot of that stuff works, let's just try to use the calculator to check these after we've kind of thought about it, because I've taught you a lot of different ways that you can actually solve these. So I'm going to go over a few of those and then just kind of maybe pause the video and see what you come up with for your answer to see if you're thinking about it right. So if you remember, I taught you that these right here, you can drop that exponent in front and you could have your 7 log 10 of 10. So that's kind of why that drops, because that's really going to be like your 7 times 1, which would come out to be 7. So when I was telling you guys about the cancellation laws the other day, those two are just going to cancel and you're going to get your 7. Okay, so make sure when you type these in that you put a parentheses around that. So when if you're using your calculator to check, please enclose that exponent and stuff inside, and then you would see that you would get 7. Okay. So go back and please put a parentheses around this. Now, if you remember, there was another way that I showed you how to do those the other day. So if you were to have log base 10 of 10 to the 7th, remember that you could write this to try to figure out what that answer would be. So I'm going to put equals x. And you would take your base to get rid of your logarithm. And you would say 10 to the x power equals 7. So then we're going to, equals 10 to the 7. Apologize. Okay, so now we notice that both of these are base 10. Okay, so that the bases are the same. So the exponent would be x equals 7. So that checks with our answer. So let's enclose the 0.001 100ths. And if you want to solve it this way, especially if you enjoy math, you would have 10 to the x power equals, and that would be tenths hundredths, which would be 1 over 100. And we talked about that as well. So we can write this with the same base. And that was, I just reversed those, didn't I? Let me fix that. Remember, if you want to flip a fraction, you need to raise it to the negative first. So 100 would be 10 to the second. And then you would have the 1 here. So I would probably write it in terms of base 10. So then I would have 10 to the negative second to flip that. So since my bases are the same, my answer is x equals negative 2. So if you type that in, since the calculator is already in base 10, we can just hit log and we can hit 0.01 and we come up with our negative 2 that we just got. So that tells us we're correct. Always check. It's just always good to check and make sure you're thinking about things right, because I feel like that helps you understand. Okay, so we have Ln. So remember that Ln and E are inverses. So let me go ahead and enclose this. Okay, so when I look at the Ln, if you remember me a minute ago, that can be written as log base E of E to the 1/4. Okay, remember that those E's, the base of the E and the base of the exponential, are going to cancel out, and it's going to drop your exponent. So your exponent's going to drop. These are going to cancel. So your answer is going to be 1/4. And I went ahead and typed that in. So you can make sure you type those in when you're checking as well. So looking at your last one, if you just want to solve this, you could put an X here and kind of just swoop around. So when I'm thinking about that, it's saying 4 to what power is equal to 16. And hopefully you know that that would be 2. And you wouldn't have to write that with the same base. So X is going to come out to be 2 for this one. And again, you can type in always to check. Now, all this section wants is definitely to use the calculator and to round to 4 places. So if you would go ahead and just do that and come back and check your answers with me, just make sure you're getting the answer I'm getting when you check those. And if not, try to type it in again. Okay, just make sure you close your parentheses. Some calculators, give you different things depending on the one you're using. So just make sure you close those to be safe. So I typed in 2 that I don't think have done before. So you can see that we're doing 33 times 978 right there. And then I did the Ln, so just close that parenthesis and make sure you close that one with your dividing. So I'm going to uncover the answers for you. And then I also wrote this out for you because I want you to be aware that, again, when you have a single log, you can expand it, because when we get to solving equations, sometimes you have to know a little bit more about changing this stuff up. So if you do expand it, you're going to get the same answer. So remember us talking about the other day, this line right here, divide means subtract. So you could take the log of both the numerator and then take the log of the denominator and subtract those and get the same decimal with those two. Okay. Okay, so remember that if the base of a graph, when you're graphing, which was the exponential, if that base is bigger than 1, it is going to be, try to think, yes, it would be increasing. Okay, so if you ever are unsure, all you have to do is try to change numbers in your calculator and compare them. So I'm going to show you in my calculator again. So let me clean that off real quick. Okay, we're going to keep talking about a few things that some of you have been making mistakes on your quizzes and homework. So the exponential shifts, just like when we talked about transformations of regular functions. So when you're looking at the exponential, the k is going to affect the range, which is your asymptote. So this one is always going to have a parenthesis, okay? Because remember, you're approaching the asymptote, but you're not going to touch it. So make sure that you put that. So let's look at the parent just a second where I can kind of explain that to you. So if I have 2 to the x power, can I raise that to anything to get 0? Because I'm looking to see if this can be raised to a number to come up with 0. So if I raise 2 to negative powers, I just get small numbers because it flips that. So if I did like -3, that's just going to go to 1 over 2 to the third, which is 1/8. So if I did -2, that would go to 1 over 4. -1 is going to invert the fraction to 1 over 2. When I raise it to 0, I just get 1. If I raise it to 1, I'm going to get 2. 2 would give me 4, and 3 would give me 8. So notice that these numbers are just kind of flipped with your reciprocals, but you're never going to get 0 out, okay? So 0 would give you 1, which is your y-intercept. So that would be right there. And if you were to graph 1, 2, and then you would go to 2, 4, and so forth. So notice like when you go to -1, 1/2, and then it just gets closer and closer, but it's never actually going to touch 0. So that's why it's very important for you to put a parentheses around that in the range. So for your domain, you can put any number in the world in for x. But for your range, you need to pay attention to that right there, okay? So with the range, you're going to have to put a parenthesis on 0 to positive infinity. So make sure you pay attention to that portion. So if I look at this one right here, and I think about what's going to happen from the parent, you're going to notice that the range is going to kind of move some things around, and it's going to affect that asymptote, okay? I went ahead and typed both of these in where you can kind of see. So the first one here is the parent. If you need to, go back and look at that, and the parent is increasing. So when you hit graph, you're going to see that the other one is moving in a different location. And notice that when you're looking at this, this becomes flatter down here, which means that's where your asymptote is going to be. So when you look, this would be your horizontal asymptote this time, which would be y equals -4. With your parent, it would be y equals 0. Okay, so this shifted down 4. Okay, so when you look at your asymptote, it is changing and it is moving to the -4. So it went from 0 to -4. So when you go to your table, you go over here and I'm going to scroll and you can see that these numbers are getting closer and closer to -4. It's not really going to touch it. It's getting closer and closer, even if this says that, okay? So make sure that you understand that it's just not putting out more and more decimals, but it is not reaching that point. It's a limit. So when you look at this one, please make sure that you put parentheses around that. And for your domain, it's going to be all real numbers, just like your parent. And for your range, we would have a parenthesis -4 to positive infinity. Okay, looking at this one, some people miss this. When your A is less than 1, it is going to decrease. Earlier, when it is bigger than 1, it does increase. Now, when we're talking about less than 1, it needs to be between 0 and 1, okay? So 1/2 would be located between that 0 and 1. Okay, so if you'll copy this second one, if you haven't, on paper. So when I typed this into the calculator, you know, it's going to move right 2 and up 1. So when you look at your parent, it's shifted over 2 and up 1, and it is decreasing. Remember, this number is going to affect your range. So notice it's kind of flattening out right there. So let me go back. So you can see it's getting closer and closer to 1. It's not going to really touch it, even though you see that. I hope that didn't confuse anybody, but it's not really going to touch it. It's going to approach it. That's why you're supposed to put a 0 on, a parentheses on that. So make sure that you put a parenthesis on the number 1. So when you see that number 1 right here, I'll go back to the graph. You can see what's happening to the range is it is increasing after 1. So from that table, if I go back up, from 1, you can see those numbers are starting to get bigger over here. Okay, so this would be, the range would be from 1 to infinity. And the domain would be all real numbers. Okay, and I'm going to talk about a few more things with the review. So when you're looking at this to get the inverse, I'm going to put the steps down for you again. Remember that you are going to replace f of x with y. So I'm going to write y equals 5 to the x. Now remember that this stands for inverse, okay? And if this is an exponential, the inverse is going to be a log. So what I'm going to do second is I'm going to interchange x and y. So that means my y is now going to become an x, and my x is now going to become a y. The third step is solve for y. So remember that you need to locate the base. So the first thing you need to do is find the base of the exponential. And you're going to write log base 5. Then you're going to circle you're going to put x equals, and you're going to circle y. So y is the inverse. So the answer is going to be log base 5 of x. Now, if you want to check and see if these are inverses, you can type those in to y equals. So I typed this in, and this time I used that change of base formula. And those calculators that don't work like mine, this is what you would want to do. So log x divided by log 5. And then when you graph, if you remember when we started the unit, these would be over the line y equals x. Okay, so they are reflected over the line y equals x. So if you go to your table, if you remember about your inverses, if 1 gives you 5, then 5 should give you 1. So when you look, these are flipped. Notice that 0 gives you 1, and then 1 gives you 0 in the other function. So we did that correctly. Now, looking at y is log base 2 of 0 undefined. And I just spoke with you about that a moment ago in the graph. So if I take it back to an exponential, can I raise 2 to any power to get 0? And the answer is no. So you cannot raise a base to an exponent and get 0. So I use the change of base formula to show you that if you do that, you're going to get an error message. So that error message tells you that it is not possible. So this would be undefined, just like when you can't divide by 0. Okay, we're not able to raise 2 to a power and come up with 0. Okay, y is the value of log 376 times 27, the same as that of log 376 plus log 27. So if you type those in, we can check and see if we have the same values. That would be the first one. And then I'm going to expand those. Whoops, that's just 27. Okay, and I get the same decimal here. And the reason is because multiplication of logs can be expanded to addition of 2 logs. So basically, it's just another way to write the problem. So what we're going to do in this last example, some of you did have trouble with this type of question where it was a single condensed logarithm and it was asked to be expanded. So the first thing you have to remember is this portion right here. So I would definitely put a note, because I know the other day in class when we talked about this, it was hard for some of you to remember. So if you have the square root of x, that is the same as the exponent of x to the 1/2. So you need to remember that a square root is the same as an exponent of 1 to the half, because the exponent is a 1 and the root is a 2. So that part is very important because you'll probably see that on your assignments and tests. So what I'm going to do is I'm going to get rid of the radical by taking that information and raising it to the 1/2 power. So I'm going to have 5r to the 5th and z to the 3rd. That's going to stay exactly the same. And I'm going to have now this exponent of 1/2 that was not there. Now that that's there, my radical can go away. I still have the log base 2. Okay, now what I'm going to do is I'm going to use the power of a power rule, which tells me that I'm going to multiply my exponents. So that would go now to 5 to the 1/2, r to the 1/2, excuse me, r to the 5/2 over z to the 3/2. And I still have log base 2 outside. Okay, now I've taken care of the exponents. So now I can take a look at how to separate this. So remember that this exponent is going to drop in front of this number. Whenever you see multiplication, it's going to be addition. This exponent is going to drop in front of this variable. The division is going to mean subtraction. And this exponent is going to drop in front of this variable z. So it looks like we're going to have the log word written. We would have 1, 2, would have it here, and then 3. So I'm thinking about 3 times as we expand this. Now remember that the coefficient comes in front, the exponent comes in front as the coefficient, okay? So we're going to write 1/2, and then I'm going to write log base 2. And then I'm going to put the 5. So that's going to go in front of that. Since this was a times, when you go back, it was a multiply. We're now going to put a plus. Now we're going to drop the 5/2 in front. So it would be 5/2. And then we would have log base 2. And we would put the r. Next, remember, was the divide. So we're going to need to drop this 3/2 in front. So we're going to have a minus this time to represent division. So we're going to have minus 3/2. Then you're going to put log base 2. And then you'll put down your z. So that was one some of you encountered on a quiz or homework that you had asked me about. So I hope that helps you. Let me know if you have any questions.